They sat in silence in a windowless room in Tokyo, studying photographs that should not have existed. The date was March 23, 1943. Commander Takeo Yoshikawa and two other officers from the Naval General Staff's intelligence section stared at reconnaissance images spread across a polished wooden table. The photographs had been taken by a Japanese submarine that had surfaced briefly off the coast of California 2 weeks earlier, its periscope camera capturing what its captain thought might be a new American aircraft carrier under construction. It was not an aircraft carrier. The vessel in the photographs was something the officers had never seen before. It was enormous, perhaps 300 feet long, with a flat open deck and a bow that could open like a massive door. The hull was crude, almost brutish in its simplicity. There was no superstructure to speak of, just a small bridge mounted on the starboard side. But what caught their attention was not the design, it was the number of them. In the background of the primary photograph, partially obscured by harbour cranes and warehouse buildings, they could see at least 6 more identical vessels in various stages of construction. And this was just one shipyard. Yoshikawa reached for another folder. Inside were intelligence reports from the previous 8 months. A naval attaché in Argentina, before his recall, had filed observations about American maritime activity. A decoded American logistics communication, intercepted 3 months earlier, mentioned something called an LST program, with production targets that seemed absurdly high. A German intelligence summary, shared through the Axis partnership, noted unusual construction activity at shipyards across the American East Coast and Gulf of Mexico. None of these reports had seemed particularly urgent at the time. Ships took years to build. Everyone knew this. Capital ships, the battleships and carriers that decided naval supremacy, required enormous investments of time and resources. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. But these were not capital ships. These were something else entirely. Landing ships, the Americans called them. Ships designed specifically to carry tanks, trucks, and troops directly onto enemy beaches. Ships that could beach themselves intentionally, disgorge their cargo, and then withdraw on the next high tide. The concept was not new. The Japanese Navy had its own landing craft. But those were small vessels, capable of carrying perhaps a single tank or a company of infantry. These American ships, if the intelligence was accurate, could carry 20 tanks each, or 40 trucks, or 500 men with all their equipment. Yoshikawa did the mathematics in his head. If the Americans were building these ships at multiple yards, if each yard was producing them at the rate suggested by the photographs, if the construction time was as short as the decoded messages implied, then within a year the United States would possess an amphibious capability that exceeded anything the Imperial Japanese Navy had ever contemplated. The implications were staggering. Every island Japan had fortified across the Pacific could be assaulted. Every garrison that depended on isolation for its defense would face an enemy that could bring overwhelming force directly onto the beaches, not gradually through vulnerable landing craft trips, but in concentrated waves of armor and infantry. He wrote his assessment carefully that afternoon. The report went up through channels to the Naval General Staff. It was read, filed, and largely dismissed. The reasoning was straightforward and, to the officers who made the decision, entirely logical. America was rich, certainly. American industry was vast, undoubtedly. But ships required time. Ships required skilled labor. Resources that had to be diverted from other priorities. The photographs showed vessels under construction, not completed ships. Even the Americans, with all their vaunted industrial capacity, could not simply conjure a fleet of landing ships into existence. Naval warfare had rules, construction had limits. Everyone understood this. They were wrong. What Yoshikawa and his colleagues had witnessed was not an ambitious shipbuilding program. It was the opening phase of the largest, fastest maritime construction effort in human history. And the terrible truth would only become clear much later, when it was far too late to matter. To understand why Japanese naval officers could not grasp what they were seeing, One must first understand what naval warfare had been for centuries. Ships were precious. Ships were expensive. Ships took years to design and years more to build. This was not merely Japanese doctrine. This was universal truth, confirmed by every major navy in the world. Before World War II, the construction time for a capital ship, a battleship, or fleet carrier typically ranged from 3 to 5 years from keel laying to commissioning. The Imperial Japanese Navy's Yamato, the largest battleship ever built, required 4 years of construction. HMS Hood, pride of the Royal Navy, took 3 years. The American carrier USS Enterprise, commissioned in 1938, spent nearly 3 years under construction at Newport News Shipbuilding. Even smaller vessels required substantial time. Destroyers, the workhorses of any modern fleet, needed 12 to 18 months of construction time. Submarines required similar periods. The idea that a useful military vessel could be constructed in weeks rather than months, or months rather than years, contradicted everything naval architects and military planners understood about shipbuilding. This understanding shaped Japanese naval strategy profoundly. The Imperial Japanese Navy had entered the war with approximately 350 major combat vessels, cruisers, and larger. This fleet represented decades of construction, enormous financial investment, and the accumulated expertise of Japan's limited heavy industrial base. Every ship was precious because every ship was irreplaceable, or at best replaceable only after years of effort. Japanese war planning in the late 1930s and early 1940s operated on this assumption. The Navy would strike first, crippling American naval power at Pearl Harbor. Then, in the months that followed, Japanese forces would secure a defensive perimeter across the Pacific. They would fortify islands, establish bases, and create interlocking zones of control. American forces, bleeding from their initial losses, would require years to rebuild their shattered fleet. By the time they were ready to counterattack, Japan would be impregnable. The mathematics seemed sound. America's industrial capacity was larger, certainly, but that capacity required time to convert from peacetime production to military output. Factories had to be built or converted. Workers had to be trained. Supply chains had to be established. Raw materials had to be secured. All of this took time, and during that time, Japan would use its head start to create defenses that American forces could not overcome, even with superior numbers. This analysis was not irrational. It was based on historical precedent and sound military logic. What Japanese planners failed to anticipate was not merely that America would mobilize faster than expected. What they failed to anticipate was that the fundamental rules of naval construction were about to change. The Americans were not planning to build ships the traditional way, with traditional methods, on traditional timelines. They were about to industrialize shipbuilding itself, applying mass production techniques that had revolutionized automobile manufacturing to the construction of military vessels. The United States entered World War II with a critical strategic problem. To defeat Japan, American forces would need to cross the largest ocean on Earth, assault fortified islands defended by experienced troops, and sustain military operations thousands of miles from the nearest major supply base. Every previous war had been fought over land where armies could march to battle or across relatively short sea distances, where naval forces could operate close to their home ports. The Pacific War would be different. Islands like Tarawa, Saipan, Iwo Jima, and Okinawa lay thousands of miles from American ports. Capturing these islands would require landing troops directly onto hostile beaches under fire. Those troops would need tanks, artillery, trucks, ammunition, fuel, food, medical supplies, and countless other materials. Traditional naval logistics could not solve this problem. Before the war, amphibious operations relied on what the Navy called boat waves. Troops would transfer from transport ships offshore into small landing craft. These craft, typically capable of carrying 30 to 40 men or a single light vehicle, would motor toward the beach, discharge their passengers, and return to the transport ships for another load. The process was slow, dangerous, and limited in scale. At Gallipoli in 1915, British and Anzac forces had attempted a major amphibious assault against Turkish defences. The operation became a disaster, with landing forces trapped on narrow beaches, unable to bring sufficient heavy equipment ashore to break through defensive positions. Casualties were catastrophic. The lesson seemed clear. Amphibious assaults against prepared defences were nearly impossible without overwhelming superiority and the ability to rapidly build combat power ashore. American military planners, studying the Pacific geography in the late 1930s and early 1940s, recognized they would face this problem repeatedly. Japan had fortified dozens of islands. Each would require assault. Each assault would need to put thousands of troops ashore quickly, along with armor and artillery. Traditional landing craft could not do this fast enough. The solution emerged from an unlikely source. In 1941, a British officer visiting the United States mentioned a concept the Royal Navy was exploring. They called it a landing ship, tank. The vessel would be large enough to carry multiple tanks and vehicles in its hold. It would have a bow door that could open, allowing vehicles to drive directly onto a beach. The ship itself would beach intentionally, becoming a temporary bridge from sea to land. American naval architects and Marine Corps planners immediately recognized the concept's potential, but they also recognized the scale of the challenge. To conduct multiple simultaneous amphibious operations across the Pacific, the Navy would need not dozens of these ships, but hundreds, perhaps thousands, and they would need them quickly, within 2 or 3 years at most, not the 5 or 10 years traditional naval construction would require. The question facing American military and industrial leaders in early 1942 was straightforward and daunting. Could the United States design, develop, and mass-produce a completely new type of military vessel on a scale unprecedented in naval history? Could they do it fast enough to matter? And could they do it while simultaneously building carriers, battleships, destroyers, submarines, Liberty ships, and the thousands of aircraft, tanks, and other weapons the war effort required? The answer would reshape not just the Pacific War, but the entire future of amphibious warfare and naval construction. The landing ship, tank, designation LST, emerged from a design competition that began in earnest in February 1942. The Navy's Bureau of Ships issued specifications that seemed almost contradictory. The vessel needed to carry at least 20 medium tanks, or their equivalent weight in other vehicles and cargo. It needed to cross oceans under its own power, not requiring a tow. It needed to beach itself on typical Pacific Island shorelines, which meant operating in as little as 3 feet of water at the bow. It needed a bow door and ramp system that could deploy quickly under combat conditions. And crucially, it needed to be simple enough that relatively inexperienced shipyards could build it in large numbers. John C. Niedermeyer, a naval architect working for the Bureau of Ships, led the design team. His challenge was essentially impossible by traditional naval architecture standards. Ocean-going ships had deep drafts, keels that extended well below the waterline for stability. Beaching vessels were flat-bottomed, with shallow drafts, but such designs were unstable in open ocean. Niedermeyer needed a ship that could do both. His solution was inelegant but functional. The LST would have a flat bottom for beaching, but would incorporate ballast tanks that could be flooded with seawater for ocean crossings, increasing stability. When approaching a landing beach, pumps would empty these tanks, reducing draft from roughly 14 feet, fully loaded, to less than 4 feet forward. The bow would be blunt and squared off, designed to ground firmly on sand or coral. 2 massive clamshell doors, hinged on the sides, would swing open. Behind them, a ramp would lower, creating a bridge from the ship's interior directly onto the beach. The dimensions were substantial. The final design measured 328 feet in length, 50 feet in beam. Displacement, when loaded, reached approximately 4,000 tons. The cargo deck, running nearly the entire length of the ship, could accommodate 20 Sherman tanks parked side by side in 2 rows. Alternatively, it could carry 27 trucks, or nearly 200 tons of general cargo, or combinations of vehicles and supplies. The propulsion system used two General Motors diesel engines, 12-cylinder units producing 900 horsepower each. These drove twin propeller shafts. Maximum speed was approximately 12 knots, roughly 14 miles per hour. This was painfully slow by naval standards, slower than most cargo ships, far slower than any combat vessel. But speed was not the priority. Reliability, simplicity, and cargo capacity mattered more. The crew complement was typically 113 officers and enlisted men. Accommodations were basic, nothing resembling the relative comforts of a cruiser or battleship. The ship had defensive armament, typically 8 20mm anti-aircraft guns and 2 40mm guns, but these were intended only for self-defense against aircraft. LSTs were not combat vessels in the traditional sense. They were floating trucks, designed to carry cargo from port to beach and return for another load. Construction methodology was as important as the design itself. Traditional shipbuilding started with a keel, the spine of the vessel, laid down in a dry dock or on a slipway. Workers would then build the frame outward from this keel, adding ribs and structure, eventually plating the exterior with steel sheets. The process was sequential, with each step depending on completion of previous steps. It required highly skilled workers who understood complex three-dimensional structures and could work metal into compound curves. The LST design deliberately avoided this complexity. The hull was constructed in prefabricated sections that were largely flat or simple curves. These sections could be built simultaneously in different parts of a shipyard or even at entirely different locations, then transported to a final assembly site. Welding replaced riveting wherever possible, requiring less specialized skill. The internal structure was modular, with standardized compartments and systems that could be replicated across hundreds of ships. This approach meant that shipyards without deep experience in naval construction could participate. Inland facilities, far from traditional shipbuilding centers, could produce hull sections. The American Bridge Company in Ambridge, Pennsylvania, hundreds of miles from the ocean, began producing LST sections in its steel fabrication plants. These sections traveled by rail to coastal assembly yards where final construction occurred. The first LST, designated LST-1, was laid down at Newport News Shipbuilding on June 10, 1942. It was commissioned on December 14, 1942, just 6 months later. This was remarkable, but still followed somewhat traditional construction methods. The real revolution came as more shipyards entered production and refined their processes. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. By mid-1943, LST production had become a genuine industrial phenomenon. The Navy had contracted with multiple shipyards across the United States to build these vessels simultaneously. Each yard refined techniques, shared innovations, and gradually reduced construction time. The statistics began modestly. In January 1943, American shipyards delivered 7 LSTs. In February, 12. March saw 18 completed, but the numbers kept climbing. April brought 23. May produced 27. By June 1943, American yards were completing 35 LSTs per month, and the pace continued to accelerate. The yards themselves represented an extraordinary range of industrial capability. The Chicago Bridge and Iron Company, which normally built storage tanks and industrial structures, constructed LSTs at its Seneca, Illinois facility on the Illinois River. These ships were launched sideways into the river, then navigated down to the Mississippi River and eventually to the Gulf of Mexico, a journey of over 1,000 miles through inland waterways before reaching open ocean. Dravo Corporation of Pittsburgh, Pennsylvania, better known for building barges and riverboats, produced LSTs at its Naval Island facility. The American Bridge Company's Ambridge Yard, the Missouri Valley Bridge and Iron Company in Evansville, Indiana, and the Chicago Works all contributed. On the coasts, traditional naval yards like Newport News and Bethlehem Steel's shipyards ramped up production alongside these unconventional builders. The workforce transformation was equally dramatic. Before the war, shipbuilding had been a male-dominated craft, requiring years of apprenticeship. Welders, fitters, riveters, and the dozens of other specialized trades had been closed professions, passing skills from master to apprentice. The scale of wartime production shattered these traditions. Women entered shipyard work in unprecedented numbers. By 1943, women comprised roughly 15% of shipyard and workers nationwide, though percentages varied significantly by yard. At some facilities, women made up nearly a third of the workforce. They welded hull sections, operated cranes, installed electrical systems, and performed virtually every task except the heaviest lifting operations. Training programs, often lasting just weeks, taught basic skills to workers who had never seen a ship under construction. The production system required extraordinary logistical coordination. Each LST needed approximately 1,000 tons of steel plate and structural steel. Engines, produced by General Motors and other manufacturers, had to arrive on precise schedules. Electrical systems, pumps, valves, piping, anchors, chains, life rafts, armament, communications equipment, and hundreds of other components all flowed from suppliers to shipyards in carefully orchestrated sequences. The Navy established production oversight offices at major yards, with officers and civilian inspectors monitoring quality, while pushing for speed. The balance was delicate. Ships had to be seaworthy and safe, but perfection was enemy of completion. Minor defects could be addressed later, during shakedown cruises or at forward bases. The priority was getting vessels into service. By December 1943, monthly production exceeded 50 LSTs. January 1944 saw 58 completions. February brought 61, March produced 74. The peak came in June 1944, when American yards delivered 105 LSTs in a single month. 105 ocean-going military vessels, each capable of carrying 20 tanks, completed in 30 days. To put this in perspective, the Imperial Japanese Navy had begun the war with approximately 350 major combat vessels accumulated over decades. The United States was now producing, in a single month, nearly one-third that number of specialized amphibious ships. And these were not small coastal craft. These were vessels displacing 4,000 tons, capable of crossing the Pacific Ocean under their own power. Japanese intelligence officers continued to receive fragmentary reports about American LST production throughout 1943 and into 1944. Submarine reconnaissance photographs showed increasing numbers of these distinctive vessels. Radio intercepts mentioned LST deployments to various Pacific bases. Decoded messages referenced logistical planning that assumed LST availability in numbers that seemed implausible. But the information remained fragmented, each piece arriving through different channels without clear synthesis. More critically, the numbers themselves seemed unbelievable. Officers reviewing intelligence reports applied their own understanding of shipbuilding to what they were seeing. If Americans were reporting completion of 50 or 60 or 70 LSTs per month, surely this was exaggeration. Propaganda meant to boost morale or deceive Japanese planners. Consider the context these officers worked within. Japan's own shipbuilding industry, one of the most advanced in Asia, could produce perhaps 8 to 10 destroyers per month at peak capacity, and this was stretching resources to the breaking point. Destroyers were smaller than LSTs, displacing around 2,000 tons compared to 4,000. They were also more complex, requiring sophisticated fire control systems, torpedo tubes, and high-speed turbine engines. But they were still just ships, steel hulls with engines and equipment. If Japan, with its experienced shipyards and skilled workforce, could manage 8 to 10 destroyers monthly, how could America possibly produce 70 or 80 or 100 LSTs? The mathematics seemed wrong. The industrial capacity required seemed impossible. Therefore, the intelligence must be flawed, exaggerated, or misunderstood. This cognitive dissonance, this inability to accept what the evidence suggested, had profound strategic Consequences. Japanese defensive planning for Pacific Islands continued to assume that American amphibious capabilities were limited. Plans called for defending beaches, certainly, but the assumption was that American landing forces would arrive gradually, in waves of small landing craft, giving defenders time to concentrate fire and counterattack. The possibility that dozens of LSTs might arrive simultaneously at an invasion beach, each disgorging 20 tanks and their supporting infantry within minutes of grounding, was not seriously considered. Such capability seemed to require hundreds of these ships, positioned throughout the Pacific, available for multiple simultaneous operations. And if the Americans had hundreds of LSTs, that meant they had built them at rates that contradicted everything Japanese naval officers understood about shipbuilding. By early 1944, the cumulative total of LSTs completed and commissioned exceeded 400 ships. By mid-year, the number surpassed 700. By December 1944, over 1,000 LSTs had been delivered to the U.S. Navy, 1,051 to be precise. Built in less than 3 years, from first design to 1,000-plus vessel fleet, the Japanese Naval General Staff possessed intelligence indicating high American LST production. They had photographs, intercepts, and reports from various sources. What they did not have was the psychological framework to accept that industrial warfare had fundamentally changed the rules of naval construction. Ships no longer required years to build. With proper design, modular construction, and industrial-scale production techniques, useful military vessels could be produced in weeks, not years. This failure of comprehension was not stupidity. It was the inevitable result of experience and expertise. Japanese naval officers were highly trained professionals who understood traditional shipbuilding intimately. That expertise became a liability when the fundamental paradigm shifted. They knew too much about how ships had always been built to accept how ships were now being built. The true scale of American LST capability became undeniable during the island campaigns of 1944. At Saipan in June, the invasion fleet included 71 LSTs. These vessels did not arrive individually over days or weeks. They arrived together, part of a massive amphibious armada that appeared off the island's coast on the morning of June 15th. Japanese defenders, dug into positions overlooking the landing beaches, watched as these vessels approached. The LSTs came in formation, dozens of them, their blunt bows pointed toward shore. At predetermined points, they grounded themselves, bow doors swung open and ramps dropped. Sherman tanks rolled directly onto the beaches, not one or two at a time from small landing craft, but in concentrated groups, platoons and companies arriving within minutes of each other. Lieutenant General Yoshitsugu Saito, commanding Japanese forces on Saipan, had approximately 30,000 troops and 44 tanks to defend the island. The American invasion force brought over 70,000 combat troops and hundreds of tanks ashore in the first few days. The logistical capability represented by those 71 LSTs meant that American forces could sustain combat operations indefinitely. Ammunition, food, fuel, medical supplies, and reinforcements flowed continuously from ship to shore. The pattern repeated at Tinian in July, where 43 LSTs supported the landing. At Peleliu in September 28, LSTs delivered the 1st Marine Division and its equipment. At Leyte in the Philippines in October, the invasion involved over 100 LSTs, part of the largest amphibious operation in the Pacific War to that point. Each operation demonstrated the same overwhelming material advantage. Japanese defenders, even when fighting with extraordinary courage and tactical skill, faced enemies who could rapidly build combat power ashore faster than defensive forces could respond. The LST made this possible. Without these ships, American forces would have required days or weeks to land the same combat power using traditional landing craft. With LSTs, divisions came ashore in hours. Japanese commanders, watching their defensive positions overwhelmed by American firepower and numbers, began to understand what the intelligence reports had been indicating. The Americans possessed industrial capacity that operated on a scale beyond Japanese experience. It was not merely that America was rich or had more factories. It was that American industry had fundamentally changed how military equipment was produced, applying mass production techniques to items that had traditionally required individual craftsmanship. Captain Toshikazu Omei, a staff officer with the combined fleet who survived the war, later wrote about the psychological impact of encountering American material superiority in the final years of the war. He described the growing sense among Japanese naval officers that they were fighting not against a military force, but against an industrial machine that could not be stopped through tactical excellence or fighting spirit. Every ship sunk was replaced by 3 more. Every plane destroyed was replaced by 10. Every loss the Americans suffered seemed only to increase their strength as production accelerated. The failure to comprehend American LST production capability was not merely an intelligence oversight. It represented a fundamental misunderstanding of the war Japan was fighting. Japanese strategy in the Pacific had assumed that distance and fortification would compensate for America's industrial advantages. Islands like Tarawa, Saipan, Iwo Jima, and Okinawa were supposed to be impregnable, or at minimum, so costly to capture that American public opinion would force a negotiated peace. This strategy depended on the assumption that American amphibious capability was limited. If the Americans could only conduct 1 or 2 major amphibious operations per year, if each operation required months of preparation and concentration of scarce resources, then defending scattered islands across the Pacific was feasible. Japanese forces could exact terrible casualties at each location, bleeding American strength gradually, buying time for negotiation or for some strategic miracle. But 1,000 LSTs fundamentally changed this calculation. With such capacity, the Americans could conduct multiple simultaneous amphibious operations. They could bypass strongly defended positions, isolating them without assault. They could concentrate overwhelming force at selected points while maintaining pressure across the entire Pacific. And they could sustain operations indefinitely because the logistics chain, supported by hundreds of LSTs moving supplies from rear bases to forward positions, never broke. Japanese Naval General Staff, even when confronted with evidence of massive LST production, could not adjust their strategy accordingly because any realistic assessment of American capability led to one conclusion: Japan could not win. If the Americans could produce 1,000 specialized amphibious ships in 3 years, while simultaneously building fleet carriers, battleships, destroyers, submarines, and cargo vessels in unprecedented numbers, then Japan's industrial base could not compete. The war was not merely difficult, it was unwinnable. This truth was psychologically unbearable for officers who had dedicated their lives to the Navy and to Japan's imperial mission. Accepting that American industrial capacity made victory impossible meant accepting that the war had been a strategic mistake from the beginning, that the decision to attack Pearl Harbor had doomed Japan to eventual defeat, and that hundreds of thousands of Japanese servicemen and civilians would die in a losing cause. So the evidence was rationalized, dismissed, or reinterpreted. Intelligence reports about LST production were filed but not acted upon. When operations demonstrated overwhelming American amphibious capability, this was attributed to temporary resource concentration rather than fundamental industrial superiority. The alternative, accepting reality, required admitting truths that were incompatible with continuing the war. By 1945, as American forces approached the Japanese home islands, the full scale of the disparity was undeniable. The invasion of Okinawa in April involved 443 LSTs, among a total force of over 1,400 ships. Japanese defenders on Okinawa dug into extensive fortifications with approximately 100,000 troops, held out for 82 days of brutal combat. But the outcome was never in doubt. American forces had the equipment, supplies, and replacements to sustain operations indefinitely. Japanese forces, cut off from resupply, gradually exhausted their ammunition and resources. The LST program's final tally was staggering by any measure. Between 1942 and 1945, American shipyards constructed 1,051 LSTs. The peak production year, 1944, saw 736 vessels completed. This was more than one ship per day, every day, for an entire year. The total represented more tonnage than the entire Japanese Navy possessed at the start of the war. But the numbers, while impressive, tell only part of the story. The LST program demonstrated that modern industrial nations could, when properly mobilized, produce military equipment at scales that would have seemed impossible in previous conflicts. The factories, workers, and organizational systems that built LSTs also built Liberty ships, Victory ships, escort carriers, destroyers, landing craft, and thousands of other vessels. American shipyards delivered over 5,000 major military and cargo vessels during the war years, transforming the United States into a maritime power of unprecedented scale. For Japan, the lesson came too late to matter strategically. By the time Japanese military leadership fully understood the implications of American industrial mobilization, reversing course was impossible. Surrender would mean occupation, the end of the imperial system as it had existed, and national humiliation. Continuation meant inevitable defeat, but allowed Japan to fight on, hoping for some change in circumstances, some miracle that would alter the outcome. Commander Yoshikawa, the intelligence officer who had studied those first LST photographs in March 1943, survived the war. In post-war interviews, he spoke carefully about his wartime service, as most surviving Japanese officers did. But he acknowledged that Japanese intelligence had been aware of American production capabilities relatively early in the war. The information had been available. What was missing was the institutional willingness to accept what the information meant. He described a meeting in late 1944 where intelligence officers presented updated assessments of American naval strength. The numbers were comprehensive, based on multiple sources, carefully verified. They showed American naval forces had grown to several times their pre-war size in just 3 years. The officers presenting this information were asked what Japan could do to counter such capability. After a long silence, one officer replied that nothing could be done. The industrial race was over. Japan had lost. The only question was how long the war would continue. That assessment, stark and brutal, was not what military leadership wanted to hear. But it was the truth that the LST production numbers had been indicating for over a year. One nation had mobilized its industrial capacity for total war. The other nation, despite tremendous courage and sacrifice from its military forces, simply could not match that mobilization. The LSTs themselves served in every theater of the war. They landed troops in Sicily, Normandy, southern France, and throughout the Pacific. After the war, many continued in service, providing logistical support during the occupation of Japan and Germany. Some served in Korea in the 1950s. A few remained in naval service into the 1960s and 70s, their simple, robust design proving remarkably durable. The men who built them, the workers in shipyards from Pittsburgh to Portland, mostly returned to civilian life after the war ended. They had been part of something unprecedented, though few understood the full scale of what they had accomplished at the time. They had gone to work each day, welded steel, installed equipment, and launched ships. The fact that their labor had helped reshape naval warfare and contributed decisively to victory was not something most thought about. They had jobs to do, and they did them. The lesson of the LST program, if there is one, is not about the superiority of any nation or system. It is about the nature of industrial warfare and the terrible mathematics of production capacity. In conflicts between modern industrial nations, victory often belongs not to the side with better tactics or braver soldiers, but to the side that can produce more equipment faster. Courage and skill matter, but they cannot overcome sustained material disadvantage. Japan's Admirals witnessed American LST production hit 1,051 ships in 3 years. They saw the photographs, read the intelligence reports, and received the statistics. But they could not, or would not, accept what this meant. And in that gap between knowledge and comprehension, between seeing evidence and accepting its implications, lay one of the war's quietest but most decisive defeats. The ships were real. The numbers were accurate. The conclusion was inescapable. But acknowledging it required admitting that the war was lost, and that admission, for those who had started the conflict, was impossible until the very end. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.